Hi, this is the first of my videos this year on how to pass your GCSE for the higher course. Now what we're going to do is we're going to use Edexcel's material that they first released back in 2015. This is their original guide to what the paper was going to look like. Since then we've had one paper, which I'm going to make in another video, but at the moment this is how to pass the first GCSE high paper that they gave. So the first thing they gave us was a multiplication of decimals. So if we've got 6.34 times by 5.32, the first thing we do when we multiply in decimals is we're going to get rid of decimal points and have 634 times by 52. Okay, so in there we've got 1, 2, 3 decimal places in the question, so in the answer is going to be 3 decimal places. Then we do 2 lots of 4, which is 8, 2 lots of 3, which is 6, 2 lots of 6, which is 12, and that's the 2 done. Now move on to the 5. That 5 causes a 50, so we have a 0 to start off with, it's a 50. 5 4s are 20, so that's 0 carry the 2. 5 3s are 15, plus our 2 is 17. 5 6 is a 30, plus our 1 is 31. We can add those together, so it's going to be 8, 6, 9, 2, 3. So we end up with 3, 2, 9, 6, 8. And like I said a second ago, there are 3 decimal places. So there needs to be 3 decimal places in the answer. So if we count from the back, 1, 2, 3. We've got 32.968, and that gets us on the way. So that's our first 3 marks. The next thing we've got to be able to do, again, relatively straightforward if you've done your revision for this, and that's multiplying out brackets. So if we do m times n, that's going to give us n squared. If we do 7 times 3, that's going to be plus 21. If we do the 7 times m plus 7m, then we do m times 3, and we've got a nice smiley face there. So that m times 3, the mouth, is going to be 3m. That gets us 1 out of the 2 marks. Then we've got to simplify. So there's no other m squareds, so that's just going to be m squared. There's a 7m plus a 3m, which is 10m. And we've got that plus 21 sitting on the end. Okay, next question. Now the key thing to notice about this is the line that says you must show your workings. That means every time you put another angle down on your diagram, you've got to say why you're putting it down there. So the first thing I always do in these sorts of questions when you've got parallel lines is look for a Z angle. And a Z angle is one that looks like a Z, but of course we're not allowed to call it Z angle anymore. But if you've learned it as Z angle, it's dead easy. So this one here and this one here makes a Z, so therefore this one must be 38 degrees. Now I've written 38 degrees, so I've written an angle down on my diagram, but I've got to say why. So, but now I'd say Z angle, so Z angles are called alternate angles. So that's 38 degrees because alternate angles are equal. You don't need to write like a 3-year-old, it's just the way I write. And then what you've got here is on this triangle here, we've got a couple of dashes. Now these dashes means it's an isosceles triangle. So if this is 38, this one here is also 38 degrees. But what I've done now is I've written another angle on my diagram. So I say that this one's 38 degrees because base angles in an isosceles triangle are the same. Now in that red triangle I've just drawn, I've drawn a triangle and I've got 2 of those angles. So the third angle must make it add up to 180. So 38 plus 38 equals 76. So 180 take away 76 equals 104. So this here must be 104 degrees. And I've written an angle down there. So I've got to say that angles in a triangle add to 180 degrees. Now what we've got is we've got an absolute mirror image above. So we've got this one here, so we've got a backward Z, so therefore this must be 38 degrees. And I'd say, because alternate angles are equal, I'd say that this one here is also 38 degrees, and I'm going to put a big old arrow around there to show that base angles in an isosceles triangle are the same, just like I have done here. And then this one is also going to be 104 degrees. I'm going to have an arrow to that there. So nice and neat. And then we've got this thing here. So if we now do another diagram, what we've got here is we've got X, and we've got that there, which is 104 degrees. We've got this here, which is 104 degrees. So if we then add those together, that's going to be 208 degrees. And I know the angles around a point add up to 360. So what would be 360 minus 208? That gives me 152 degrees. And again, I've got to use the term angles around a point add to 360 degrees. And that should be everything you need for that question. That question's only worth 3 marks. I felt like it took me an eternity to do it, but as long as you get used to doing it and writing down the reasons as you go, it should be relatively straightforward. And the more you do of those, the easier it becomes. Right, now this question here is all about average speed. So whenever you've got average speed, the first thing I write down, if it's 80 kilometers an hour, is I write down that 80 kilometers equals 1 hour. And Gary drove from London to Sheffield, and it took him 3 hours. So if he was travelling at 80 kilometres for 1 hour, in 3 hours, we just need to treble the distance. That's going to be 240 kilometres. So what he's done is, just draw the UK here, just like that. Apologies for any offence caused. So he's gone from London to Sheffield, and that's taken 3 hours to 240 kilometres. So 240 kilometres from London to Sheffield. Lynn also drove from London to Sheffield, and she took 5 hours. So she's going to do the same journey. It's going to take her 5 hours. So therefore, for Lynn, 240 kilometres equals 5 hours. Assuming that Lynn drove along the same roads and she did not take a break, work out her average speed. So if she goes 240 kilometres in 5 hours, average speed is how many kilometres you go in 1 hour. So I'll do 240 divided by 5. So one of the new things in the GCSE, you've got to be able to do division quite easily. So how many times does 5 go into 240? 5 doesn't go into 2, so we carry 2 over. 5 goes into 24 4 times, with 4 left over. 5 goes into 40 8 times. So that's going to be 48 kilometres in 1 hour. So therefore her speed is 48 kilometres per hour. And that's how you do that one. If Lynn did not drive along the same road as Gary, explain how this could affect her answer to part A. So let's say Lynn didn't do that. So she sort of travelled this road to get to Sheffield. Therefore, she's done a lot more kilometres, but she's still done it in 5 hours. So you need to say that if she travelled further, so if she did more kilometres, then that average speed would be greater. If she actually took a shortcut and only did like 120 kilometres, but it still took her 5 hours, then her average speed is going to be less. So that's what you need to say. You need to say that if she didn't drive along the same route, if she drove along a route that's longer, her average speed would be greater. If she drove along roads that are less long, her average speed would decrease. Okay, now this question. Whenever I've done this question with students in the past, I hate it. And the reason is because there's no numbers here. No numbers of the people that work in the company. So bear in mind it says what percentage of all the people in the company are under the age of 25. Percentage means per 100. So let's just make up the number and say that 100 people work in this company. So if there's 100 people and the number of men to women is 3 to 2, then I've got to share 100 in the ratio 3 parts, which is men, and 2 parts, which is women. So in total, there are 5 parts of this company. Now 5 parts equals 100 people. So 5 parts equals 100 people. Then 1 part, if I divide that by 5, is 20 people. So therefore, if we've got 3 parts of men, that's going to be 60 men and 40 women. Now, that's that bit done. So we've got our marks for dealing with those numbers. Now, 40% of the men are under 25. So if we've got 60 men, we've got to do 40% of 60. Now 10% of 60 equals 6. So if I times that by 4, that's going to give me 40%. So 10% is 6, times it by 4, it's going to be 24. Therefore, it's going to be 24 men. But 24 men are under 25. Always worth writing down what this means. So it's 24 men under 25. And 10% of the women are. So if there's 40 women and 10% of them, that means it's going to be 4 women under 25. So what percentage of all the people are under 25? Well, there's going to be 24 men and 4 women. So that's 28. That's only if there's 100 people. So that means 28 out of every 100 people are under 25. And 28 out of 100 as a percentage is simply 28%. And that's based on us using 100 as our starting number. If we'd have used 200, then what we'd have ended up with is 56 out of 200. Well, 56 out of 200 is the same as 28 out of 100. So again, that would have given us the same amount. So just make up a number. Just make sure it's a nice, easy number to use. And usually 100 is the best number to use there. Okay, so we've got a plan, a front elevation and a side elevation of a solid prism. Our plan is the bird's eye view, so that's looking straight down. Front elevation is as you're looking at it front on. Side elevation is just from the side. So let us do the 3D sketch. So the way to do a 3D sketch is to always draw the front elevation. So we've got that. And then from the side elevation, I'm just going up to the side there. So whenever you're drawing 3D, all of my red lines here should go out at the same angle. And then the lines that connect those which are the black lines here, should go just horizontally and vertically. And there we go. Now we've sketched it, what it looks like from the side. And if we have a look at what that looks like from above, yep, that's fine. From the side, looking this way, yeah, that's fine. It says write down the dimensions. So this is on centimeters squared paper. So therefore we can see here that this here is 5 centimeters. And we've got this here which is 4 centimeters. We've got this here which is 2 centimeters. We've got this here which is 3 centimeters. You can say that one there is 2 centimeters. So this one here, that's the side elevation, so that's going across there, so that's going to be 3 centimeters. And all of these are going to be 3 centimeters. And I think that's about enough for that one. That's all the units that you need on that. Okay, next question. 1,200 students at a party, and Kate is going to organise a party and she's going to order pizza. Kate takes a sample, so a sample is just like a small snapshot. And she asks each student to tell her one type of pizza that they want. And the table shows her results. Look at how much ham pizza Kate should order. So from her sample, 20 out of this 60 people want a ham pizza. But I want to know how many to order for 1,200. So can we make 20 out of 60 the same as something out of 1,200? There's a few ways of doing it. We could cancel the fraction down, 2 to 6, which is 1 to 3. So a third of the people want ham pizza. So 1/3 of 1,200 equals 400. Alternatively, what we could have done is 20 out of 60, write that, so it is something out of 1,200. So if we times the top and bottom by 10, that's going to be 200 out of 600, which is the same. If we double that, that's 400 out of 1,200. So therefore, we want to order 400 ham pizzas. Write down any assumption you make and explain how this could affect your answer. We're assuming, so the assumption here is we're assuming that these 20 here are representative of the school. We're assuming that they're not just the only 20 people in the school that like ham pizza. If they're the only 20 people in the school that like ham pizza, they've got to share 400 between them. But if this 20 is representative, so representative, if the sample is representative of the population or representative of the whole school, it means that it's going to be accurate. So the assumption that we're making is that the sample is representative of the whole school. And again, what that means is that the sample represents what the whole school wants. Explain how this could affect your answer. If the sample isn't representative, then we've either got far too much pizza, if this number's too high, or far too little pizza, if this 20 is too low. Okay, now these questions appear every single time. They've been in every other paper as well. So what we've got to do is we've got some algebra and we've got it within a shape. So there's always going to be a shape on your question, on your exam paper. There's always going to have some algebra there. So in that case, what you want to get is something equals something. Now, in this sort of question, opposite angles in a parallelogram are the same. So if they're the same, that means that 5x minus 20 equals 2x plus 43. So with that in mind, we've got to try and solve this. So if I've got 5x and I've got 2x, what I need to do is get all the x's on one side. So I'm going to get rid of 2x on this side, but again, it's the whole thing with algebra, it's a set of scales. So if I get rid of 2x on this side, I've got to get rid of 2x on this side, which leaves me with 3x minus 20 equals 43. See, all I did there was I just got rid of 2x's. I've now got to get rid of this minus 20. Now the way we get rid of minus 20 is we add it onto the other side. So I'm going to add 20 onto this side. So I've got 3x equals 63. Once I know that 3x equals 63, I then work out what 1x equals. So I divide by 3, and again, 3's into 63, 3's into 6 go twice, 3's into 3 go once. So that's going to be 21. So I now know what x is. So x equals 21. Now the other thing that you need to know about parallelogram, once we know that x is 21, is we know that these here are what we call allied angles. So they add up to 180. So, or I could say that these two are allied angles because they're parallel. So parallelograms, they're parallel. So these two have to add up to 180, or these two have to add up to 180. But rather than saying 2x plus 43, I know that x is 21. So 2 lots of 21 plus 43. 2 lots of 21 is 42, plus 43 is 85. So I know this angle here is 85 degrees. So I know that this plus this equals 180. So 85 plus 4y minus 5x equals 180. Now again, I know what 5x is. 5x is 5 lots of 21. So 85 plus 4y minus 5 lots of 21, so 21 times by 5, 105. So minus 105 equals 180. 85 take away 105 is going to be minus 20. So I've got 4y minus 20 equals 180. Now the way I get rid of minus 20, just like before, is I add it on to 180. So 4y equals 200, y equals 50. And that's that question done. So the whole thing about that question, you don't need to get 100% on it, but you just need to pick up some of those marks. And whenever you've got algebra in a shape on a question, you need to have something equals something. And so we had this thing equals this thing. Very often it's an isosceles triangle, and we say that one angle equals the other angle. That's how we set up our algebra. Okay, next one, standard form. Love about this. So whenever we multiply two standard form questions, a lot of people think it's like x plus 2 times by x plus 5, so we do the smiley face method. That's not true, because this isn't 9 plus 10 to the power of minus 4, it's 9 times 10 to the power of minus 4. So when we multiply standard form numbers, the first thing we do is we multiply the main numbers together, so 9 times 3. So 9 times 3 is 27, and then times by, we're going to multiply these things together. Now, just like if you had x cubed times by x to the power of 5, we add the powers. So that's going to be x to the power of 8. So 10 to the power of minus 4 times 10 to the power of 7 is going to be 10 to the power of 3. Now, that almost looks like standard form, but the one thing is that this number needs to be between 1 and 10. So it can't be 27, it's got to be 2.7. So 2.7. Now, if we've made this thing smaller, to balance it out, we've got to make this power bigger. So 2.7 times 10 to the power of 4. And that's it. That's our answer. 2.7 times 10 to the power of 4. You don't need to write it down here. I mean, it's useful for the examiner, but you don't need to. As long as you've got it written somewhere there, you're going to get your answer. Okay, next thing, you just need to remember what the power of a half means. The power of a half just means the square root. We're going to do the square root of 64. So something times by itself equals 64, which of course is 8. For the smart Alex amongst you, it can also equal minus 8. Either one of these would be the correct answer. And the reason why it's minus 8 is because a minus times by minus. So minus 8 times by minus 8, negative times by negative, is going to be a positive. That would also equal 64. So the answer is 8, or if you're being cocky, minus 8. Or, if you're being extra cocky, 8 or minus 8. But I don't want to confuse you. As long as you remember that the power of a half means the square root, that's all you need to know there. Right, I'm going to do a slightly simpler version of this question first of all, and that would be 8 to the power of minus 2, because we need to know how to deal with negative powers. So the way we deal with negative powers is we make them positive, but we've got to do 1 over. So 1 over 8 to the power of 2. So that would be 1 over 64. So whenever you have a negative power, we do 1 over and just write it out with a positive power. Here we've got a fraction to a negative power. So the way we deal with that is we just flip the fraction upside down. So that's going to be 125 over 8, the power of 2/3. Right, now again I want to do something else here. I want to do 81 to the power of 3/4. Now the first thing we deal with is, if we've got a fraction for a power, is we deal with the bottom first of all. Now the bottom means the root. That means the 4th root of 81. Now whatever that answer is, we're going to cube it. Now the 4th root of 81, so the 4th root of 81 means something times something times something times something equals 81. So 3 times 3 is 9, times by 3 is 27, times by 3 is 81. So that is going to be 3. So it's going to be 3 cubed. 3 cubed is 3 times 3 times 3. That should be 27. However, that isn't our question. We've got a much harder question here. But it still stands. We've got to deal with this bottom first of all. So we've got to do the cube root of 125. So something times something times something makes 125. And that something is 5. On the bottom, we've got to do the cube root of 8. So something times something times something is 8. A little bit easier, and that's 2. And then once we've dealt with the 3 on the bottom of that fraction, we deal with the 2 on the top, which means that we've got to square it. So 5 squared is 25. 2 squared is 4. Now, well done for you, you've got that, because that isn't easy at all. If you have got it, or if you sort of picked up a couple of bits and pieces there, that's fantastic. Remember, Rome wasn't built in a day. You've got some time for your exam. Just do something, pick up something new every day. One uranium atom has a mass of 3.95 times 10 to the power of minus 22. Work out an estimate for the number of uranium atoms in 1 kilogram of uranium. I don't know, sometimes a load of words are a little bit confusing. So what you do instead is you make the numbers nice and easy. So one uranium atom has a mass of 4 grams. Work out an estimate for the number of uranium atoms in 20 grams of uranium. So one uranium atom has 4 grams. Work out the number of atoms in 20 grams. Okay, so if we've got 20 grams and each weighs 4 grams, it needs to be 20 grams divided by 4 grams. So that goes in there 5 times. So now, by making the numbers nice and easy, what that means, I've worked out what to do. So I've got to do 1 kilogram divided by this in grams. But notice that this is kilograms and this is grams. So I'm going to make this grams. So I need to do 1,000 grams divided by 3.95 times by 10 to the power minus 22. Well, hang on. Bear with, I think I've done that wrong. No, of course I haven't. I just realised that it says estimate. Right, so I've got to do something divided by this thing, which looks horrendous. If it says estimate, why don't we say that's going to be 4 times 10 to the power minus 22. And if I'm going to do division, why don't I make this 1 times 10 to the power of 3. So I'm going to write this divided by this thing. So now I'm so beforehand we were multiplying standard form numbers, now we're going to divide. So first thing I've got to do is this thing divided by this thing. So 1 divided by 4 is a quarter, which is 0.25 times by, and then beforehand when it was multiplying we multiplied the powers. So now we've got to divide, so we've got to take away the power. So 3 take away minus 22. So 3 take away minus 22 is going to be 25. It's going to be 0.25 times 10 to the power of 25. And again, that's not right because that's got to be between 1 and 10. So I need to make this thing bigger. That's going to be 2.5 times 10 to the power. And if I've made this thing bigger, I've got to make this thing smaller. So power of 24. That's it. 2.5 times 10 to the power of 24. Okay, so the next thing is your answer to A, an underestimate or an overestimate? So what I did to do the whole estimating thing, I made 3.95 into 4. That's where I did the estimating. So I've got a number and I've divided it by another number. I'll need to know whether or not rounding this up has made it a bigger number or a smaller number. So let's take another example. If I've got 100 and I divide it by 4, well, let's say I rounded it up and did 100 divided by 5. So 100 divided by 4 is the actual answer. So 100 divided by 4 is 25. But I rounded it up to 5. So my estimated answer, 100 divided by 5, would give me 20. So this is what my estimated answer would be. This is what the actual answer would be. If I round up the number underneath, I actually make the estimate smaller. So it needs to be an underestimate. So the reason why it's an underestimate is because the number that you're dividing by has been rounded up, has been made bigger. So if you divide by something bigger, that makes it an underestimate. Quite a hard one to get your head around, that one. But if you can, lovely jubbly. Okay. Now this one here, pressure equals force divided by area. So we've got the pressure, which is 900, and we've got the area, which is 60 centimeters squared. So it looks dead easy, 90 divided by 60. However, it says give your answer in newtons per meter squared. Now this is centimeters squared. So we've got to convert centimeters squared into meters squared. So what we've got to do is we've got to turn this 60 centimeters squared into meters squared. Now I know that 100 centimeters equals 1 meter, and so a lot of people say that 60 centimeters squared equals 0.6 meters squared, but that is entirely wrong. And the way to do it is just do a diagram and do a rectangle which has an area of 60 centimeters squared. Now the easiest way to do that is 1 centimeter by 60 centimeters. Now this will give 60 centimeters squared. And then turn this into a meter. So 60 centimeters will be 0.6 meters. 1 centimeter is 0.01 meter. So 0.01 meter times by 0.6 meters. 0.01 times by 0.6. 1 times 6 is 6 with 1, 2, 3 decimal places. So 1, 2, 3 decimal places. So 0.006 meters squared is going to be that there. So, going back to this question, 60 centimeters squared equals 0.006 meters squared. So we've got to do 900 divided by 0.006. And so we're divided by a decimal now. The key thing here is being able to convert between centimeters squared and meters squared. So 900 divided by 0.006. Dividing with decimals, what we're going to do is we're going to times top and bottom by 10. So that's going to be 9,000 divided by 0.06. Times by 10 again. 90,000 divided by 0.6. Times by 10 again. 900,000 divided by 6. And then we can simplify that. So if we divide by 3, that's going to be 300,000 divided by 2, which equals 150,000 newtons per meter squared. And that is how you do that one. So first of all, we've got to be able to convert between centimetre squared and metre squared. And once we've done that, we've got to know how to divide with decimals. And the way we divide by decimals is we times by 10 top and bottom as a fraction until we're not dividing by decimals anymore. Okay, the final question for this video is we've got rectangle ABCD is mathematically similar. So therefore, mathematically similar means that it's an enlargement. So what I'm going to do is I'm going to draw out the smaller one and I'm going to draw out the larger one. So ABCD. So A, B, C, D with dimensions 10 by 4 is mathematically similar to DAEF, so obviously on its side. DAEF. And obviously that one has got 4 centimeters. So what we're going to do is we're going to work out what the scale factor is. What do we times 4 by to get to 10? So 10 over 4 is the same as 5 over 2. 5 divided by 2 is 2.5. So the scale factor you get from here to here is times by 2.5. So in order to work out what this one is, you're going to divide by 2.5. So we've got to work out what 4 divided by 2.5 is. And again, just like this, just like we did beforehand, 8 as a 4 over 2.5, we've got a decimal. So we can either times by 10, or if it ends in 0.5, we can double it. So 4 divided by 2.5 is the same as 8 divided by 5. So we can say that this is 8/5, or 1 3/5, which equals 1.6. But 3/5 is the same as 6/10. We now know that this DF here is 1.6 centimeters. So if we've got to work out the area of this, we've got to do base times height. So it's 4 times by 1.6. So 4, if we get rid of the decimal point and do 16 times by 4, 4 6 is 24. 4 1s are 4 plus 2 is going to be 6. That's going to be 64. That's going to be 64, but we need to have a decimal point in there, so it's going to be 6.4 centimeters squared. And that is the first half of the paper. Now, if you manage to get all of those questions absolutely spot on, well done, because some of them are rock hard. But if you are able to do that, then you're looking at a grade 7. So, good job. I should do the other video, revision video, tomorrow.